And to look at example 2b, it says to solve the unknown value for the following points on the unit circle, where x is unknown and y must be equal to -1. So let me bring up the whiteboard and let's work on that one down a little bit. Okay, so we had that x comma -1. So if we were to plug this into the unit circle equation, we get x squared plus -1, again, which would need to be squared, is equal to 1, which would leave us with x squared plus 1 equal 1. And solving for x, we could subtract 1 from both sides, which would leave us with 0. And taking the square root, we'd have x equal to 0. Plus or minus 0, but we get just one solution. So we would come up with the solution that if y is equal to -1, x must be 0, which would be right 0, down 1. So that point and of course that's the point on the unit circle because it's kind of like the extreme point on the very southern tip of the circle. But if the center is at 0 and it's a radius 1, of course that point would make sense. And notice that the other points, right 1 up 0, which is 1 comma 0, also 0 comma 1, right 0 up 1, and of course left 1 up 0 are four of the more pivotal points, the ones that are not in the quadrants. Um, Sometimes they're called quadrantal angles, but anyways, those are all points on the circle, and those are kind of obvious because if x squared plus y squared must be 1, of course 1 comma 0, whether it's positive or negative and whether it's x or y, all make sense as solutions to the unit circle equation. So, coming back to uh, another thing that's very important about the unit circle, uh, and things I want to talk about are what we call, they're very specific points. So when a lot of people think of what the unit circle is, they often think of a filled in unit circle, which looks kind of like this from your packet. And we're going to get to this in just a minute, but uh, the unit circle is really just a circle, and that's kind of what I'm stressing the importance of. It's a circle. Its equation is x squared plus y squared equal to 1, and there's a lot of different points that can work on it. I mean, it's an infinite number of points work on it because it's a continuous line, circle. But um, this sort of diagram, which is what a lot of people think of when they think of what is the unit circle, it is basically a table of values. It's very specific values that are points with that are on the circle. It's not every point, it's just some of them. It's some of the easier points to remember. And one of the things I wanted to work to next is, well, what are all these points? What is all this information? Why does this make any sort of sense? So what the next part on the handout says, it's discussing a lot of the terminology about the unit circle, which is necessary to describe the general layout of it. So on the unit circle, we have what's called an initial point. Basically, 1 comma 0 is defined to be the initial point. And when it comes to trigonometric functions, we need to have a starting point. Well, this will make sense why later, but basically we're arbitrarily choosing 1 comma 0 to be our starting point, and basically every other point is considered relative to that point as a distance away. So a terminal point would be a point, any other point along the unit circle. And like for example, imagine the point 0, comma 1, which is at the top of the circle. Um, you could imagine that as being a particular distance away from the initial point. We can kind of think of it as a straight line where each point along the unit circle is a particular distance from the start. Or one way I like to phrase it is, imagine that you're an ant and you're on the rim of the rim of a car or the tire of a car, whatever. You can start walking along that tire, and you can wind up on any point. The initial point is just where you start. The terminal point is where you're going to end up after that movement. And in our notes in our book, they actually don't use t. They do it just a little bit. They use a little bit of different variables, but I'm very accustomed to using t for the distance to the terminal point from the initial point. So say, for example, the ant is walking along the circle like that. We can imagine them traveling a particular distance and adding up as it goes. Um, also, what I wanted to mention is that a counterclockwise movement is treated as positive movement, like in a positive direction, whereas if the ant were to move clockwise instead, that would be considered what we call the negative direction when it's when referring to the unit circle. And there is a very specific reason. It's because when we're going in the positive direction, we're moving into the first quadrant of the xy axis, which like all the points up here are positive, right? Because like say for example, we're going to look at that point right there, which we actually solved that point a minute ago. Root 2 over 2 comma root 2 over 2, both are positive because we went right and up. And if we're going down, we're going into the negative direction because we're going down. So going upwards from the initial point is the positive direction by definition. Technically, you could define the other way it to be the other way around, but it's just sort of like, well, right, like if you've ever thought about, well, why is to the right positive and to the left negative on an XY graph? It's kind of arbitrary. It most likely stemmed from the whole right-handedness stigma. But anyways, I'm getting off topic as per usual.